Hey guys, so today we're going to be going over the 3 different types of synthesis reactions. We're going to use some of the problems from our assignment 2.7.1. And so here's number 1. So the first thing that we got to look at here is that we are adding water to this non-metal oxide. So we can tell just by seeing the H₂O that it's going to be either number 2 or number 3 from the reaction types, not number 1. And then the second thing that gives it away is that we have sulfur, which is S, which is a non-metal. So that's how we know that it's going to be the third reaction type. Okay. And then here we have hydrogen, and we're also going to grab the charge for sulfite, because these are the 2 things that we will be using, that we will be connecting. So I've already gone ahead and written down the form. So we have hydrogen and sulfite, and then we add the charges on there, which we just found out. And what we will be doing after that is we will be crisscrossing them. So we will put the 2 down in front of the H and then the 1 in front of the SO3. And remember, if we put down a 1, it's redundant, so we don't really have to write it out. I'm just showing you so that way you know that it's supposed to kind of go there, but it's invisible. So this would be our answer. We just check and make sure that both sides are the same. Next, we have number 2. So on this one, same thing. Like I said, the giveaway here is that we have water, that we are adding water, so it can either be reaction 2 or 3. And then we look at Mg, which is magnesium. We know that that is a metal. If you check, it's right over here. And so we know because it's a metal, it's going to be reaction type number 2, which means that we will be using the pattern where we have that M and that OH. That stands for hydroxide, and we're going to do the same thing for magnesium this time. So we're going to replace M with magnesium because that is the metal that we are using. Okay, now that we have that, the next thing is to look up the ionic charges of each one of those things. So magnesium has a +2 ionic charge, and then hydroxide has a charge of -1, which I will show you right now. So if we zoom in here into our polyatomic chart, you will see that it is a -1. All right, so we come back to our problem, and we will go ahead and plug in that -1, and then we will crisscross them. So that way we have the number 2 outside of the parentheses of the hydroxide, and then we have that -1 in front of the magnesium. And remember, the 1 is always redundant, so we don't really need it, and that's why I will be erasing it. And so this is your solution. Just make sure that they are both balanced, both sides. In this case, it looks like it is. So we are good. Nothing else is needed. Okay, so then for number 3, we look at this, we analyze, and we see that there is no water, so it cannot be reaction type 2 or 3, so it's got to be reaction type number 1. So now all we got to do is combine the elements. So we combine aluminum and we combine oxygen together. So the next thing we're going to do is we're going to look up the ionic charges for aluminum and for oxygen. So we have a +3 and a -2 for oxygen. So we bring it back up here, write them down, and then we are going to crisscross them. So that 2 is going to go in front of the aluminum, and the 3 is going to go in front of the oxygen. And then next, we just got to make sure that they are balanced. So I will start writing out all of my elements just to see how many atoms of each I have on each side. And for this case, what I will be doing is I will be multiplying the the left side by 2, my aluminum, so that way it can match the one that I have on my right side. After this, I will go ahead and multiply my oxygen by 3, so that way I have a 6 on my left side, and then on the other side, I will multiply by 2, so that way I can have a 6 for that oxygen. But there's an issue here. It also affects my aluminum, which makes it into a 4. So now I have to go back to my left side, erase that 2, and put a 4 instead, so that way my new number is not 2, it's 4. And I made a little mistake there. I was trying to scratch out the 2. And then that's pretty much it. It's balanced and it's combined, so we're good. Okay, and so for our next one, we analyze it again and we see that there is not any water, no H₂O. So we know that it is not case 2 or 3, but it's going to be reaction type number 1. So then all we got to do is combine iron and the chloride together. And we're just going to do iron and chlorine, so just those 2 elements. And then we're going to look up the ionic charges for each one of those. So for metal, you notice that it's in the gray area. And so for this one, the most common one is going to be 2, so we're going to use 2. But if you wanted to use 3, you could also use 3. And if you gave me that, then I would still count it correct. But for this case, we're going to use number 2. And then chlorine, we have that it is -1. So then we are going to crisscross these. So now that means that I have a 2 in front of the chlorine, and then my iron is just going to be a 1, but it's going to be redundant, so we're not going to write it. And then the next thing, I just got to make sure that it is balanced, which in this case, it looks like it is. So that is my final answer. All right, for this next one, we have aluminum being combined with some nitride. And so we see that there is no water, so we know that it is not going to be any of the type 2 or type 3. It's going to be type 1 reaction. So all we got to do is combine them. So we have the aluminum nitride, and we get the charges. So aluminum has a charge of +3. Nitrogen has a charge of -3. Okay, so in this case, we will write both of those down, and we can still crisscross them, but I want you to understand something here that's important. Whenever both of these charges are the same, we will reduce the ratio, or we will try to simplify the ratio to a 1-to-1 ratio because they are the same numbers. So we don't have to write the 3's, we bring it down to 1's, and because they are both 1's, we just leave it blank. So this is the correct way to write it, with no number in front of each one of these. Now I'm just going to count how many atoms I have on each side, and I'm going to start by balancing out the right side, multiply it by 2. So that's going to multiply my atoms of aluminum and nitrogen to 2, and then on the left side, I will multiply my aluminum times 2, so that way it can be equal to my right side, and then everything else is balanced. So this is my final answer. Okay, now we have copper with bromine that we are combining, or bromide, and we see that there's no water, so it's going to be type 1. We're just going to have to combine both of these elements together. So it's just going to be copper bromide. And now we select the charges for these. So for this one, again, another common charge of copper is number 2, since it is in the shaded area. And then bromine has a negative charge of -1. So we're going to put -1 and a +2 on top of copper. Now we're going to crisscross these. That 2 is going to go in front of the bromine, and then that 1 is going to be in front of the copper. We drop the charge, or the signs, just need the numbers. And remember, the 1 is redundant, so we don't even write it there. So I'm just going to erase it. Okay, good. So now you just got to check if these are balanced. It looks like this is balanced, so this will be our final answer. Okay. Next, we got zinc, and it's combining with oxygen gas. We don't see any water, so it's going to be the first type, and so we just got to combine the elements together. We look for their charges, so we look for zinc. Zinc has a positive 2 charge, and oxygen has a negative 2 charge. Remember what I said in that previous problem? Whenever we have the charges equal out to one another, they basically almost cancel each other out and simplify down to a 1-to-1 ratio. So we just write ones. But then, like I said, ones are redundant, so we don't even have to write them. So we're good. So that is why I crossed these two out, because they just represent a 1-to-1 ratio. So now I just got to make sure that these are balanced. So I'm going to write how many zinc and oxygens I have on the left side and on the right side. Oh, and I made a little mistake there. It's not 2 oxygens, it's just 1 on the right side. So now we see this, it's not even, so I'm going to put a 2 in the coefficient for the right side, multiply those times 2. And now I have 2 on each side, on the right side, but the left side is not even. So I'm going to multiply my zinc by 2. And that makes everything balanced, and that is my answer. Okay. Next one. Well, we see that we have water in there, so it's either going to be case 2 or 3, and the next one is potassium. We know that potassium is a metal, so we know that we're going to use case 2. So because we have that case 2, we're gonna just write down that pattern. So that M is going to be replaced with our K that we have from the potassium. And we're going to put hydroxide in parentheses. Next, we're going to look for the ionic charges for each one of our, for our element of K, and then for the polyatomic ion of hydroxide. So K is +1 and hydroxide is -1. So they are in a 1-to-1 ratio, which means that we can crisscross them, but they're still going to be the same. Now that we have this, we crisscross, and like I said, the ones are redundant, so we technically don't even have to write them down. It's just so that you understand what's going on. So I'm going to erase them. And the next thing that I'm going to do is I'm going to make sure that both sides are balanced out. So I'm going to start off by writing out my elements on each side. Okay, and so far I've written out all of my atoms for each side. So I'm going to multiply the right side by 2. So that way I can balance out with what I have on my left side. And that simple molecule change fixes everything. All right, next one. We have arsenic pairing up with chloride. And in this one, we see that there is no water, so it's going to be the first type of reaction, where we're just going to have to combine them. We look for arsenic's charge. So we have a +3. Even though at the top it says -3, it's going to be positive because metals have a positive charge since they give away electrons. And chlorine is going to have a -1 charge. So we're going to crisscross both of these. That 3 is going to go in front of the chlorine, and then that 1 in front of the arsenic. So we would just write it like this, the 3 in the front. And I'm going to erase that 1 because it's redundant. Next, I just got to make sure that these are balanced out. So I'm going to check on what I have on each side as far as atoms. So for arsenic, I have 1, chlorine, I have 2. On the right side, I have 1 arsenic and 3 chlorines. So let's see, this is what I'm going to do next for these. I am going to multiply, I'm going to add a coefficient on my right side for 2. And that's going to transform that arsenic into 2 and that chlorine into 6. And now I just have to do the adjustments on the left side. So I'm going to multiply by 3 my chloride. That's going to give me that 6. And then I'm going to multiply my arsenic by 2. And now it is balanced. So this is my answer. Circle this, and that's it. Okay, here we have our last example. So in this one, we do have water, so it's not going to be case 1. So then we have to look at this area right here. Is this aluminum a metal or a non-metal? It is a metal. So we are going to use the second type of reaction. So now that we know this, we are going to combine them. And we are going to use the aluminum followed by hydroxide in parentheses. The next thing we're going to do is we're going to look for the charges. So aluminum has a charge of +3, and then hydroxide has a charge of -1. Okay, perfect. So now we're going to add our charges, and then we are going to crisscross them. And put that 3 in front of the hydroxide and that 1 in front of the aluminum. And again, 1s are redundant, so we do not write those down. Now we just have to make sure that they are balanced. So I'm going to start off here by writing out my elements. Aluminum has 2, oxygen has 4 of them because we are combining the ones that are all of the oxygens that we can see on the left side of the arrow. And then we do the same thing for the right side. All right, so I'm going to start off here by multiplying my right side by 2, a coefficient of 2, and that's going to change all of the elements that I have on the right side to 2, 6, and 6. Then I'm going to focus on my left side to try to get a similar amount to the right side. So I'm going to multiply this times 3. That should transform my hydrogen into 6. But now it also changes the number of oxygens that I have in total on the left side. So I have 6 now, and then 2 aluminums. And this is balanced. So now I can just go ahead and circle my answer, and that's it. Well, I hope that this was helpful to you. Bye, everybody.